Hello everyone, welcome to today's video. In this video, I'm gonna share the last achievement of the project, which is using the state machine in a proper way to control the brick. So I uploaded the video on YouTube channel, and in this YouTube channel you will see that the machine will start moving forward, and as soon as it detects the obstacle it will turn right, and then there is a touch sensor on the right side which if it's get pressed the whole machine will stop and the program will shut down. So let's see a few seconds of this video. You see that it's moving forward and the ultrasonic sensor detect the object, it turns right, and there is another one, so it should turn right again. In a more detail we will go through the code to see what's going on in the code. So now it will turn again, and there is another one, it will turn again, and the touch sensor will stop it. So you can watch this video on the YouTube channel if you like. And I also put the YouTube channel link in the repository, so if you go to the Git repository and search for project Linz 2020, this name here, search it in the Git, you will find the repository and you can access the YouTube channel link. Also you can search it on the YouTube, just simply search the project Linz 2020 again in the YouTube. So you will find it there too. And if you search it on Google, you may end up with my LinkedIn page, which I always provide the link to the repo and the videos also in my LinkedIn. So you can also access to the videos from there too by searching on the Google itself. So let's get started. There is a since you remember in the from last videos, I want to do a quick recap. So because I got some feedbacks which are basically pointing out that these topics are getting more and more complex, and it needs for the people who are watching to go through lots of things to understand what's going on in the new video. So in this video, I'm gonna do a little bit of recap about what we have done in last 3-4 videos. So let me first start with the problem definition and what we did so far. So let's get started about some recap, and then we will go through the new stuff again later in this video. So if you remember in the first state machine video, I talked about some basic of the state machines and the definition, and then I said that we want to use the Papyrus and Spring State Machine to model our state machine. And in the second video and third video later on, I said that there are some problems and I am going to solve those problems, and now we solve those problems. But let's start first from the scratch, and this is the state machine definition that we want to have. So we have an ideally state, a forward state, a turning state, which is now named as a navigation, and then reset. And this cycle is actually what we want to go through. And there is also this is a super state. There is a super state, which are these are the substate of the super state, and all of these states are going to stop if there is an a stop signal coming in. So the whole system will shut down and stop. And but what was the problem last time? We wanted to model our state machine using the Papyrus, and the Papyrus will gives us a UML file. If I have it open somewhere, I guess I need to go to another branch. So let's see. If you come here, I still have an example experimenting with state machine using the Papyrus. So in the Papyrus, Papyrus gives you a UML file, which this UML file is basically the structure of your state machine, which you did on a uh, visual tool of the Papyrus. So you can use this UML file later on in combination with the Spring to instantiate the state machine instance and then use it for the further usages. So if I can open here, I have an example, I guess, somewhere in here, I guess, exactly here. Yes, as you see, basically the state machine is a part of uh, the Spring application ecosystem. So I'm using the state machine, and the state machine is smart. The framework is smart enough to understand that I'm using a UML. So I'm giving a path to the UML file to the framework, and the framework basically take care of this configuration on the background and generate a state machine for me based on what I have defined in the Papyrus. And Papyrus basically is giving me a UML file, which this UML file is used to generating the state machine for me. And the configuration is basically done via the UML file. What I need to do in this uh, way of using the Spring State Machine is that I just need to implement those method and action basically, which the state machine will call upon them. And this is the part that you need to do explicitly. And the state machine, the framework will not generate those for you. It will generate the state machine and configuration and the transitions from where to go. But what action should need to do and the logic in each action, you need to implement it separately. Now, since we had the problem with the break had the old version of the Java 1.7 running on it because I had I used the Lechus on the brick, Lechus Debian distribution on the brick, and also that was very old version, so it couldn't support some of the new functionality of the Java. So what I did, I update the brick to a newer version of the Java. As you see, we have now a new version running on the brick. So I use the EV3 dev, which I provided the link to their main site where they do the tutorials and the last video, so you can find it there. So I updated the brick, so the brick now runs the new version of the Java 11, which is much newer than what I had before. So I can use frameworks like Spring now, but I have another problem. The Spring has a very big overhead. So when you compile and want to deploy your code on the machine, it wouldn't be deployed because the file is extremely big. So I used another state machine framework, which is basically the state machine framework called Stateless4j, which is a very lightweight state machine framework. And I basically need to define my state as an enum and the triggers also as an enum. And later on, I need to configure the state machine. So I need to say explicitly from the ideal state, for instance, when I'm entering, I'm doing this certain action and I'm permitting this transition forward from the ideally to moving state. So basically, if I want to draw it, it would be something like, let's say here, if I want to draw it, I have my, so if I want to draw, I have this state. And then I will go from this state to a new state called moving. And then there is a transition called forward. So this is the forward transition. So from the ideally with the forward transition, I will go to the moving. So basically what we are doing here in the configuration is that making that picture as a code and using it to realize our state machine with the help of this framework. So further on, if you look, you have another transitions from, for instance, moving to navigating when there is a block event coming through, and from navigating to resetting a state when the reset transition coming through, and from the resetting to ideally when the ready transition coming through, and all those states are going to the stopping state whenever there is a stop coming through. So it's pretty fast forward, so there shouldn't be a problem with that. And later on, we have defined our action. The actions are basically wrapped into these commands